All right. Well, happy Wednesday. Um, Trying to remember what the plan was for today. We are going to practice some stuff that was not exceptions and modules, right? Was it testing you guys wanted to do? I think it was testing, right? Because we have to do testing for project. Because we finished exceptions and modules, right? We did our lab on exceptions and modules. That went pretty well. What? Yeah, project three is due a week from today because we started a little bit late. So with project three, right, we're working on classes and then testing our classes. So how do we test that it does what it's supposed to do without having to put it in sort of a main loop and do the like, yeah, we're going to use the program. So that's one way to test it. But if we weren't using the program here, we would want unit tests. And really, this is going to be better than using the program anyway, because it's not going to eyeball things, right? It doesn't rely on us looking at it and saying, yeah, that's right. It relies on us making the computer check it. So we did some testing here with like the chair class and the electric car class. Right? We had our tests. We said, oh, okay, let's make sure that when I charge my car, these things happen. Let's make sure that. So this one is kind of big and ugly. The testing in the init, all of the values that I expect to get back out, are they actually there in that instance of electric car? These are kind of dull. But our functions that do something like charge should make sure that it stops at the max, right? Because we wrote that code to say, hey, when you charge the car, don't go above the max. If you went over max, stop at max. So that was how we were testing it. In Drive, right, we had two different tests for Drive. We had Drive when it was successful, and we had Drive when it was unsuccessful. Because this idea, I want to have 100% code coverage. I want all of the lines of code in my class to run when the tests run. If the only thing I ever test is that if it's successful, I'm never checking the other piece here. I don't know if that's going to work. And in this case, we have the value error. Right? We changed this one up a little bit, and now our tests actually don't pass. So we can take a look at how we can fix that. So we run our test Drive unsuccessful, we're getting a value error. So unsuccessful, then, it's no longer going to be returning this false result here. And Drive successful, I don't think we actually get a Drive result either, so that's interesting. Oh no, we are returning true. So we're still returning true if it worked. So really, we don't need to return true if it worked. We just do it here. We can remove that bit because we're just either it's going to happen or we're going to raise an exception. So we can change up our tests. So now we run our tests again. It's not the external libraries. We'll have to fix these tests. But now we want that new behavior of the exceptions happen. So we don't care about the drive result being true. So we don't need to compare them here. We just call drive. It should not raise an exception, and then these two values should change. The odometer should change, and the current kilowatt hours of my battery should change. I used some energy, right? So that should fix up this test. Oops, let's see. Test drive successful. Uh-oh. We didn't have enough. Oh, when I took out the return true, if you don't return, the next line of code runs. So now we have to be a little more careful here and put this in our else. Right? Either we do this or we raise the exception. Before, when we had return true, we didn't need an else because it was redundant. When I took out the return, the else was no longer redundant. And this is why we have tests, right? These are the sort of things as we're modifying our code, like, oh yeah, sure, that should be fine. It wasn't fine. Right? This hopefully you're seeing tests are useful for that. Right? We'll go back and run the other test. So when it fails, when it's unsuccessful, we want to assert that it's failing. So when we call drive, we can try drive, and we're going to accept a value error as E or error or something like that, right? So we expect to get this error here, right? So there's a couple ways to do these here. There's like the nice way, and then I'm going to show you the ugly way first here. So I'll have this is my error message equals nothing to start. And then in my accept, I'll set my error message equal to a string of the error. Like I want to convert error to a string and save that as error message. And then I can assert, now I will have an actual or an expected error message. So I don't have this for the drive results. So I have an expected error message. Should be that unable, where did it go here? My code. Not enough charge to drive that far. Right? That's what we expect to get out, right? We expect our error message to be not enough charge to drive that far. I'm going to try and I'll handle the exception and not crash and set my error message. And then I can assert that my expected error message is we should call this the actual error message, right? Actual error message. Error message, we just need car.drive, actual error message. So we'll compare the two error messages. We'll try this, grab the exception, get the message out of it, and let's see what it is. The rest of the code we still want to run. After drive fails, we still want to get the odometer and get the current kilowatt hours, right? Let's give that test a run. Yeah. So you can handle any specific type, right? This can be anything here. Like if you want to catch everything, you just say exception. And we haven't really got to this why this works yet. We'll get there. This is inheritance. All errors are exceptions. That's probably enough for now. But generally, you want to be specific about what you're catching because if it's something that's not the value error, I have no idea why it blew up on me. I probably don't want to handle it because I don't know what went wrong, right? So you can have two different catch blocks. That was the piece in Zybooks. So you can catch an arithmetic error as error here. You can catch this one, or you can do different things based on the different ones. So that was their little BMI example, right? So like when you divide by 0, you don't want one of those sorts of things. So you can have multiple accepts. Yep. All right, so let's give this one a run, and let's see if this takes care of our fails then. All right, it passes. So it successfully was unsuccessful. Seems a little silly, right? But we're making sure if my code says you can't do this, that you can't do it. Right? That's what we've changed in our code. We said, okay, raise the value or force them to either handle it or crash. So this is the forceful way for my class to communicate with whoever's calling this code that they did a bad thing. Right? Just returning a true or false, they might ignore it. And maybe that's all we wanted. That's okay. When we design our code, we get to pick what we're doing. Right? But if should be some sort of catastrophic bad event, this is an exception. Something exceptional happened. You did a dumb thing. We can use exceptions. And then they have to deal with it. They have to try and catch it, or crash. And no one likes when their apps crash, right? It's super embarrassing to have your app crash. People should be ashamed when their apps crash. Now that we know how to keep them from crashing, right? So we're adding to the list of things we should feel bad about. Right? Having repeated code, you should feel bad about yourself. If your app crashes, you should feel bad about yourself now. These sort of things, because you know better now, right? You can do better. I believe in you. You got this. Okay, so that was some of the testing for our car class here. So for item and shopping cart, right? Item has quantity, name, and price. Sets and gets are pretty easy, right? No big worries there. But get total price. This is something we can test, right? If I set a quantity and I set a unit price, right? I want 3 bananas at 30 cents each. It should cost me 90 cents for the total price, right? So I can test the init, test all the gets. Those are fine. We did a test for set color, right? I think we had a test set color in here. Where'd it go? Because that's something you could do. Yeah. So test the sets. If you want to test all of the sets at once, you can do that. If you want to do them individually, it's probably slightly more proper to do them all individually here. But again, just like with the gets, I'm not going to do individual tests for each individual get. I'm just going to lump them all together here. So this is sort of just a stylistic preference. Right? The idea with a unit test is it tests one small unit of code at a time. So small units at a time are good to test. So testing 5 different set methods, set functions is not quite idiomatic. It doesn't quite follow our pattern here. But if it's literally just you're saying, hey, when I set the code, I just accept this value. Where did it go? Set color. It's not very interesting. If you've got logic there, like, hey, you can only set it to be black or blue or green or yellow, anything else gets ignored, then maybe you need some more interesting tests, right? Then it's worth doing more with. If you're just accepting the value, it's really dull. Just try it once and lump them all together if you want. So for item, right, you can set quantity and you can set price, but you can't set the name, right? Once you have bananas, it's never not a banana, right? You can put it on clearance. You can change the price and say, okay, it's an older banana now. We're going to clearance it off. Perfectly fine. You can change the price of it, but it's still a banana, right? I guess at some point it turns into like mush, but it's still banana mush, and you just throw it out of it. But we're not going to let you change the name, right? Change the quantity, change the price. So hey, I put 7 bananas in my cart, and my daughter got excited. She wanted more, so now we have 10 bananas in the cart. Right? I can change the quantity of the item in my shopping cart. Perfectly fine. Okay? So that's the item class. This string method, right? We're going to override the string method. So how do we want to represent ourselves as a string? I think we did that in one of these, didn't we? Did we do a string in here? Yeah, we did for the chair, right? Um, this obviously we're going to fix this one later, but if you have this underscore underscore str method, this is how you turn yourself into a string here. Whatever you want to have there, right? That way we can print out the chair. I think we did that. Where did I print? I thought I printed the chair somewhere. Let's try running this. Yeah, I'm a chair. Yeah. So this is the proper way to do this because everything can be turned into a string in Python. If you don't have this method here, when you turn yourself into a string in Python, you get this garbage. We haven't talked about inheritance yet. We'll get there, but so it says, hey, you're a chair object. You're an object of the chair class. You're an instance of the chair class. Here's your memory address. This is not useful at all. But if you want to print a chair, if you want to print an electric car, if you want to print a something, you'll get this. So adding this in tells whoever's using your class, hey, here's the string representation of my class. Rather than, again, we want to not tie ourselves to a specific usage. If our class can print, the only place that can be used is when it's a console application, someone sitting here typing in a black box. It can't be used in a web application. It can't be used in a mobile application. It can't be used in a graphical user interface application. It can only be used here. And the goal of classes is reusability. We want it to be independent of how someone will use it. So, and this is a more flexible way. If they want the string version, they can put that in the GUI. They can put it in the web version. They can put it in your mobile app. Right? If it just prints, we lose a lot of functionality there. So one of the ideas is that our classes are not tied to input output, right, at the text at the console. That's all. So functionally for us, it's doing the same thing now, but it allows us to do more interesting things with it later. So yeah, a lot of classes will have this string here. So you can return like what we want here are how about self.color. Let's do this as a formatted string, right? So we'll do a little f string, black, or whatever color, chair, um, at, and here's my self dot height in centimeters.
Well, no, that we return the color instead of having a lot of like air stuff.
Yeah. So this is the details of this particular instance here. So when I run this now, I'll get, here's a black chair at 90 or what, CM or something like that with, I don't know, with the seat at heat set to 90 CM. Sure. Like whatever we want here, right? Now we can set this is the string representation of that chair. And I can have multiple chairs, and each one will get its own color with its own height things. We can figure out with wheels or not. Um, we can say with, and here's the silly. So we can say, is it, this is self dot has wheels. No, isn't it wheels? Dot has wheels. So if has wheels is true, goodness, this is ugly. Then we want wheels. Oops. If it's not true, right? I think I'm backwards. Is it the question mark first? I hate these ternary. Nope, it's colon first. Wheels. Otherwise, it's no wheels. All right, let's give that a run. Oh goodness. Invalid format specifier for type. What did I get wrong here? Has wheels. Colon. Oh yeah. Why the question mark is not being recognized? Is it the question mark? I thought it was the colon. Oh, I'm backwards here. So this is wheels, has wheels, colon, no wheels. If has wheels. Oh my goodness. I'm failing at this. Hang on. Python There you go. Question. A if else B. Okay. So A if B else. That's what it is. Sorry. I can never remember the syntax here. So this way we can put it in one line. This is totally obnoxious. I'm sorry. But if you have wheels, you get wheels. Otherwise, you get no wheels. That's all. So now we run that. That should work for us. So this is with wheels. Yay, because we have wheels. And if we set this to not have wheels, right? Eric's chair, let's say Eric's chair dot set or what has wheels is false. I think we just gave full access to that. We didn't make that one private for some reason. We probably should have had a set method for it, right? But we didn't. We said this one's not private. Sure. Now we run that again. Should get both versions with wheels and with no wheels. Yep, wheels and no wheels because we changed it. That's all. So that's the string representation here. So we could write a test for the string output as well, right? Instead of having to eyeball this here, right? Let's go add a test. So let's go and go to our chair test. I'm going to right click on it and say go to test. It says there's no test. Let's make some new tests. Let's test, how about change height for now and set color for now. Sure. And we can add it more there. So it doesn't always give you everything. So I'm going to define test string given self. So I'll have a expected string is this one, right? That's my expected, right? I'm going to arrange. I'm going to act. I'm going to assert. Right, the next thing I need is a chair. Chair equals chair. Test. Shoot, we got to import it here, right? Are we not importing? Import main.chair. That's what it is. So main.chair, right? Because that's the module. Module's named main. Here's the class. Import chair. Okay. So that's everything I need to test here. Now what is my actual string is chair or string of chair, right? And then we can assert. Self.assert equal my expected string and the actual string. Let's run the test. It passes. So we got out a black chair with seat, no wheels, or with wheels. So in terms of code coverage, technically every line of code is running, but I haven't tested the other case here. So while it's going to look like I've tested everything, I haven't actually made sure that this works with no wheels, right? So I probably want to do that, right? This is string with wheels, right? It might be a little overkill, but like we're actually going to test all of the code here now. This is with no wheels, right? No wheels. So after we make the chair, we're going to say chair dot have wheels is false. Right? And then we'll get the string out and see what happens. Right? If we wrote the code, it's worth testing, right? Any code that's worth writing is worth testing, right? All right. So how about our set color? Right? Well, we're going to make the chair, and then we're going to set color and get the expected color. So we'll have an expected color is, how about blue? We'll make a chair equals chair. Here's main.chair, right? Chair.set color, given the expected color, and then we'll act. So my actual color then is going to be my chair.get color. And then we'll assert the expected color and the actual color. Let's give that one a try. Right, it passes. So we can change the color of the chair. Right? If you wanted to, you could get fancier. You could have like, what did the color start off as to make sure it actually changed? Again, I know that it started as black, and I set it to something that wasn't black. So I'm okay with this. You can get as complicated as you want with your tests. Not super, we can have an expected starting color is black after we make the chair. So now, I'm sorry, this should have been the set here. So we'll have a actual starting color, chair dot get color, set the color, get the color. So this is what we're testing, right? We're testing all three of those. Then we can self assert equal the expected starting color and the actual starting color if you want. So starts as black, changes to blue. Right? Oh, my test change height failed because it's empty, right? We didn't test change height yet. So if we look at chair and look at change height, bless you, we've got two different things that can happen. So in terms of getting 100% code coverage, I want a test to make sure this one happens, and I want a test that makes sure this one happens. Right? Over the max and under the min. So I need two different tests for this. So this is change height under min and a test for over max. Right? So we make a chair and have an expected height, those sort of things. So what is our default for these? Defaults are 45 and 125. Sure. Again, we didn't add set. We'd probably want to add some set methods here because if I give you public access to these, if I don't say that they're private variables with this little underscore, you can go and change these. What if you set the min to above the max and forget to change the max? You're like, hey, this is a bar stool chair. The minimum's up to 150, but never change the max to 125. Like, it's going to be weird, right? Yeah.
So we were seeing that for competence, that they found this out competence.
So yes, but you can change it if you try hard. You should not change it, right? So once I have a chair, right, I can say chair dot underscore what was it? Oh my goodness, color, right? Underscore color, yellow. I can do this. Python will let me do this, but you should not do this. So because it's private, if you go and change something that's private, you're essentially you're ripping off the warranty tag. Like once you open up your phone, the warranty is null and void. Once you start changing private values, the warranty is null and void. You got no idea what the class will do. So, but it hides it. So when I say chair dot, notice I don't see any of those private variables on the list here. Right? It's hidden because that's the convention. Python's trusty. It trusts people to do the right thing, but it lets you go shoot yourself in the foot if you want to. You want to go change private values? Go for it. You should not. But Python says, go for it. Yeah, you must know what you're doing. You're changing private values. So, uh, so yes, it marks them as private, but it's other languages like you cannot change private values. It won't compile. Python's like, sure, go for it. Have fun. So it's just a little different than some other languages, how they work. So it's a convention to mark it as private, not necessarily a hard and fast rule. That's all. So we probably should have sets for minimum and maximum, right? That would make more sense and make these things private so you don't do dumb things with these or set the minimum to negative. You want to have a hole in the floor for your chair? Sure, you set it to negative. Now you have a hole in the floor. Okay, sure. You want to set the max to 10,000? Sure, now you're sitting on an antenna. Like, we're not preventing any of that from happening here in the class. If the class should prevent things from happening, then add it. That's the idea. We're encapsulating all those details, right? We're protecting the integrity of our variables. Like for electric vehicle, you can't charge the battery more than the max charge. Right? The max charge is the maximum charge for the battery. You can't put more juice in this thing. Like, we're not going to let you do that because that breaks the laws of physics, and we're going to model that in our code, saying this can't happen. Right? That sort of thing. So if we're writing flight control software for an airplane, when someone wants to descend and they're at ground level, don't let them descend. Right? Don't fly below the ground. That's a bad thing to do with the plane. Right? So any sort of behavior that we want to add to our code, we can add. It depends on what we want to have happen with our values. Right? If these values are important to stay within a certain range that makes them valid, we keep them valid because we write the code for it. So you can't take your current kilowatt hours of battery above the max or below zero. Our code doesn't let you do that. Right? You can drive it all the way down to zero, run out of batteries if you want, or you can charge it all the way up to max, go anywhere in between, but the code doesn't let you go above the max or below zero. Right? Those are the sort of details. We're encapsulating all that into our class here. Those are the details. You can interact with it with the public functions we give you. You can charge it, you can drive it. Those will change your charge. That's the only way you get to change charge. We give you those public methods. All right. So that's what we do with classes. So our item class, right, has string, has get total price, and then sets and gets for quantity, unit price, just a get for name. You probably want an init method. Now, it does not require that you can init and give it values, but if there is no set for name, If you don't have name in the init method, how does it ever get set? You can't, right? So if there are no set methods for a variable, they have to be passed into the init. That's the only way they get set. So that says when you make an item, set the name, and now it's fixed. You're stuck with that item name. That's how we do that with the init method. If you got sets, go for it. You can give them defaults and then go and change it, right? And then shopping cart then has that list of items, like we did with the gradebook, right? Gradebook had a list of students, student had a list of assignments. Shopping cart will have a list of the item class here, where I'm going to have a function for add item that takes an item and adds it to its list of items. I have a function for receipt, returns a string of the receipt, each item with details and total price, and then a grand total of all the items. So we have to loop through all the items here, right? Getting out their string, adding it to the receipt, and then calculating the grand total, right? Getting the total price of each item, adding those all together as we go. And then our unit tests. If I set up an item, do I get what I expect? If I set up a shopping cart, do I get what I expect? Right? The receipt should be $0 when I have nothing. If I add 3 things, I should get the grand total, right? You need at least more than one thing to make sure your grand total is doing it right. If you just add one item, you might have a bug depending on how you're calculating your total, right? So you want at least 2 items, right? And then the program that actually lets you use it. Right? This will be independent here. So ideally, you'll have a module for shopping cart and item, and then you'll have a separate part here. It's not required, but that's the nice thing to do, right? Put your class in a module, and then put all your code that you're actually going to run somewhere else. That way, that module can be passed around because your shopping cart class is so good, we're going to use it everywhere. We're going to turn this into a multi-million-dollar web app. Go for it, or a mobile app, right? We love shopping carts. All right, does that make sense in our tests? All right, so we've got until next week before class to get this one done. I don't actually have much more today because we did exceptions and modules. So we've got some time to work on this. On Monday, we're going to start new stuff again. Every Monday we start new stuff. Let's take a look. Let's see. So we've got, I'm sorry? Files. Yeah, I love files. So we'll be using files on the final project. So files let us store data when the program's not running. Right? Like our gradebook, every time I hit run, I had to go re-enter everything. That really sucked. It's not very useful. But if I can save all the data to a file and then read the data back out of the file, right? Read and write my files, I can keep data around between runs. So I can save my gradebook, come back and open it. Right? That's actually useful, right? So we'll look at how we use files to do those things. We'll use them in our final project. Then we got a week off for Thanksgiving break. We got inheritance. We're just touching on the topic. We don't go super deep here because, again, this is a topic for 2001. We'll do a deep dive in it, a whole project on inheritance, and then a little bit on recursion and some other cool stuff for data science and libraries. Like we're just touching on it to show you this is how you would go use them. We're not actually getting into the libraries. You can go do that when you do your machine learning classes and data science classes and those sorts of things. We're just focused on the Python piece here. The last week of class I've got set aside just for work time, so I can answer your questions. Again, the goal here is that you can get it done by 12/6, ideally. I know it might not happen, but I want to try and give you some time so you can get ahead on it so that when we do our final presentations, you've got nothing else to worry about. You had it done for the week. You can actually focus on your final exams for classes that have exams. I just hate exams. And thankfully, that was the one nice thing that happened out of COVID. They're like, we probably shouldn't do exams. We should do projects. Like they sent out a whole recommendation to all the faculty. Like this is probably a better way to measure success because exams over COVID were risky at best, right? For unscrupulous people. It's really hard to police those sorts of things. And thankfully, U of M came out against those awful tools like HonorLock. And they're like, hey, take a scan of the room that you're in and make sure there's nothing else around here. And then like things would get flagged and you get alerts. And like in the middle of your test, they're like, please look up the screen. And like breaks your concentration on trying to take an exam. And then you do horrible on them. Those sorts of tools are just awful and invade your privacy. And I hate them. So anyway, final projects sort of, we got the idea of them and I was able to keep them. And no one told me otherwise. So all my classes have final projects instead of final exams. So I'm super excited. When it comes to the final project, we'll talk about it more next week, but it will have some very specific requirements to even be accepted. So the goal here is that I make sure you're actually doing the work and not cheating. That's sort of why I have them here. And then to help you. So you'll have to have at least 10 commits across 10 different days of working software where every time you commit, you should be able to run. something will happen. We're going to iteratively build this and develop it and write it and add features and add pieces and add pieces and add pieces. So we're going to build out a little bit and make sure it runs. Build out a little bit, make sure it runs. Build out a little bit, make sure it runs. Build out a little bit, make sure it runs. If you can't get to 10 commits over 10 days, my thought is you probably just went online to ChatGPT and copy pasted it in and gave me one commit. That's what some people have done before. And I'm like, you didn't write this. And they're like, oh, you're right. I didn't write it because it doesn't look like their code. It's hard for me to find those things nowadays, right? Because then you ask the chatbot, hey, can you make it look like a first year student wrote this? And then it goes and makes it sloppy instead of looking all sorts of silly things. But that's the goal. And then that you've got something working as you go is actually beneficial for you because you're checking off the items off the rubric here. Okay, I got this part going. Okay, now I can focus on this part. Now I can focus on this part. Now I can focus on this part, right? Helping you along as you go. And then because it has to work every time, it's really hard to take an answer from ChatGPT. You could break it into 10 pieces and commit 10 different pieces, but it won't run. Right. So I'm telling you my strategy here because I know you're all going to do great and actually do your own work because you care about learning. Right. That's fantastic. Love you, folks. That's good. But that's why I'm going to have this requirement for 10 commits over 10 days with working at least 10. You can do more, right? That's the minimum here. So we've got a month to work on it. So I expect at least 10 commits over 10 days to even grade it. If you can't get there, you're not going to get a grade on it. And if you don't get a grade on it, it's really, really, really hard to pass the class to when you can't get 40% of the score. It means you literally will fail, right? You get 60 or less without it. Technically, you could get a D minus if you've got 100% of everything else, but that's still failing, right? So you've got to do the work, put in the work here. Now you can use the chatbot to help you with it. That's perfectly fine. I'm okay with that. It's a tool, right? We're going to use it to help us be more efficient. But like English paper rules, you have to do your own work. You have to add original effort to it, right? It's not just one giant quote. That doesn't fly, right? And even when we get into industry, we're not just copy pasting directly from AI, right? What the work we're going to be doing is using what it helps us write to solve our problems and taking pieces, making sure the pieces that it gives us are correct because it doesn't always give us good stuff, right? I think we tried that on one of the midterm questions, right? And it just completely bombed it, didn't it? Is it one of the midterm questions, or was it the encryption question? It just could not do. Remember our encryption lab or fake encryption? Sorry, it's not even the right word for it. Like it just had no idea. And it's like, here you go. So again, verifying it knows what it's supposed to do is part of what we're learning, right? Because we have to understand the pieces here. So that's what's coming down the pipe. Looking forward to it. It should be a lot of fun. We are almost done with new material, right? So we got files, inheritance, recursion, Python for data science. We'll come back to all these topics again. Files, not so much, but inheritance and recursion will come back to in the next class. The other tools you'll come back to in other classes. We don't have time to get into the libraries. We're still focused on the basics. Well, I suppose here's some cool stuff you can do with it, right? And that's what we got going on. Okay. All right. Other thoughts, questions, concerns? Sweet. We'll call it a day. So work on the project. Let me know how it's going, and we go from there.